Hi, and welcome to this video. Today I'm going to give a brief introduction to the friction lab. You're going to be completing this lab whether you're in person or at home working remotely. So in a previous video, you should have learned that different materials have different coefficients of friction. Coefficient of friction, again, is how easy or difficult it is for materials to slide on top of each other. Coefficient of friction is also often represented by the Greek letter mu, which is kind of the U letter here with the front tail hanging off there. The objective of this specific lab is to explore exactly what the value of coefficient of friction is between certain materials. So again, the question that we're going to try to solve as we progress through this lab is, what is the specific value of coefficient of friction between various materials? So coefficient of friction is something that we can't necessarily always determine physically or see physically in front of us. When we pull on something, we might be able to determine, like the frictional force is pretty high, but we're not going to be able to determine exactly, what's the coefficient of friction between these two materials. So we're going to work through this lab, and eventually through all of our data and our experiment, we're going to determine exactly what the specific value is of the coefficient of friction between different materials. So here's our lab setup. We're going to have a block on top of a table with some mass, and we're going to pull on the block to the right with some applied force so that the block moves with constant speed. So in this lab, again, it's just a block on top of a table as opposed to the previous lab where we had a cart with wheels on top of the table. Again, we're going to move it so that it moves at a constant speed. That's really important, and I'm going to talk about why in just a couple of minutes, but it's going to move at a constant speed. Here we have our surface-to-surface contact, which is where our coefficient of friction is. Here in pink, that is between the two surfaces of both the block and the table. So that's that interaction. In this lab, our independent variable, or what we're going to change, is going to be our mass. So we're going to add masses as we go so that the applied force is different. With that being said, the applied force is our dependent variable. So that's what changes as a result of changing the mass. Again, the independent variable, or what we're changing, is mass, and the dependent variable is force applied. That's what changes as a result. Now, you might be thinking, okay, our independent variable and dependent variable don't actually have anything to do with coefficient of friction. But we are going to determine the coefficient of friction by using science. We're going to collect our data with these two variables and then use some graphs and graphical analysis to then determine what our coefficient of friction is. So we're not actually going to directly get it from our data, but we're going to get it using some graphical analysis. Okay, so this equation should be familiar to you as it was introduced in another video. We have force friction is equal to our coefficient of friction times our normal force. You might be thinking, well, our two variables that we just talked about were mass and force applied. Neither of those are in this equation. However, we're going to find force of friction and normal force using the variables that we're looking at in the lab. So in order to do that, let's first take a look at the free body diagram of the block. The first force I'm going to put on here is applied force. We're going to be pulling the force to the right, and it's going to move to the right. Again, that applied force is our dependent variable. That's what's going to change as we change the mass. Since the object is moving to the right, there must also be a frictional force to the left. So this is the friction lab. So of course there's friction between the block and the surface of the table. Now, I did mention earlier that we were going to move the block with constant speed, and that was important to this lab. So the fact that the block is moving at constant speed means that the frictional force and the applied force are equal and opposite. So because the block does not accelerate at all, that must mean that the net force of the forces in the x direction are equal to 0. Therefore, the frictional force and the applied force are equal. So when we find experimentally the data for our force applied, that is equal and opposite to the frictional force. So once we find the applied force, we will have in turn found the frictional force. Okay, so that takes care of one variable in the equation. Now let's take a look at the normal force. So to start, we of course have a force due to weight on our object because there is mass on this block. So we remember that the equation to find weight is mass times gravity. We'll notice that mass here is in blue. That's because mass was our independent variable. Again, that's what we're changing as we go through the lab. So as we progress through our trials, we're able to determine what the weight is during each trial based on how much mass we have on our block. Okay, so now that we have weight, the last force here on our free body diagram is the normal force. So since the block is resting on a table, the surface is exerting a normal force upwards on the block because normal force always goes perpendicular to the surface. So it directly opposes the weight here. So again, since the object is not accelerating in the vertical direction, we know that the normal force and the weight must be equal and opposite as well. Because there is no net force, the net force is equal to 0. So here we were able to determine the normal force by knowing what mass we had. So once we had the mass, we can multiply by gravity to get the weight. And once we have the weight, we know that the normal force is equal and opposite to that. So we have our main equation here that the frictional force is equal to the coefficient of friction times the normal force. And I just described how we're going to find the frictional force by using the applied force. And we're going to find the normal force by using the mass that we use in the lab. But you might be thinking, well, this lab was all about the coefficient of friction. That's what we're trying to determine. But we haven't really found that yet. We haven't done anything with that yet. So we're going to move on now to go to graphing to figure out what the coefficient of friction is. So I'm going to pull up our question here. Our anchoring question, and the reason why we're doing the lab, is to figure out the specific value of the coefficient of friction between various materials. Again, here's our equation just as a reminder, so we have it in front of us. And here's the graph that we're going to create. We're going to graph the frictional force on the y-axis and the normal force on the x-axis. Again, the normal force here goes on the x-axis because it's directly related to our independent variable. Our independent variable was the mass of the system. Mass then led us to find weight, which is equal and opposite to normal force, so it makes sense that our normal force is on the x-axis. Similarly, frictional force is on our y-axis because it's related to our dependent variable, which was the applied force. So we're graphing here frictional force by normal force. You might notice here that the purple line is a linear line that starts at the point 0, 0. So that means that we have a directly proportional relationship between frictional force and normal force. Now that we know that there's a proportional relationship, what we can do is we can figure out what the slope is of this line. So the slope is, of course, rise over run. The rise here being the force of friction, and the run being the normal force. And force of friction divided by normal force is equal to coefficient of friction. We know that from the equation on the left here. So we can now label our slope as mu. So now that we know that the slope is going to be equal to coefficient of friction, we can find that using graphical analysis. So once we graph all our data in graphical analysis, we can add a best fit curve using proportional. And then in that little table that pops up in the little chart, it'll show us what the value of m is. Reminder that m is the slope of the line. So we'll just take a look, find m, and that'll be the value of our coefficient of friction between the two materials. In this lab, you're going to repeat this process 4 times so that you get the interaction or the coefficient of friction of 4 different setups. So reminder, in this lab, we're going to have a block on a table. We're going to apply some force. There's going to be an equal and opposite frictional force in the other direction. The mass that we're changing will lead to a different normal force as we go. We're then going to graph the frictional force and the normal force. And then using the slope, we can find the coefficient of friction between the materials. So with all that being said, it's now time to get ready to do the lab. I hope you guys do well, and I wish you luck.